This is our second example involving solubility product constants. In this problem, we're given the molar solubility and we want to calculate KSP. So the first thing I need to do is write down the chemical reaction. So I've got solid calcium phosphate dissolving in pure water. So that'll dissociate into 3 calcium ions and 2 phosphate ions. All right, so what we're going to do is build our ice table and then use the equilibrium concentrations to calculate the KSP. Of course, calcium phosphate is a solid, so it doesn't appear in my equilibrium constant expression. So I won't put any values in my ice table. We're given the solubility in pure water, so the initial concentrations of calcium and phosphate are 0. So the change in calcium will be 3S. The change in phosphate will be plus 2S. And so at equilibrium, I'll have 0 plus 3S is just 3S for the calcium and 2S for the phosphate. Now in this problem, we were given the molar solubility, so we know S. So at this point, I could plug in the value of the solubility for S and get numerical values for these positions in my equilibrium row of the table. But I find these problems are easier to solve if I wait, plug these values into the equilibrium constant expression, then once I simplify that, then go ahead and plug in the value for the molar solubility. And I feel like it just makes the arithmetic easier and I'm less likely to make simple math mistakes. So my equilibrium constant expression for this reaction will be KSP is equal to the concentration of calcium cubed times the concentration of phosphate squared. So now I'll take my equilibrium values, plug them into the equilibrium constant expression. So I end up with KSP is equal to 3S cubed times 2S squared. So we have plenty of room. I'm going to finish this one on the next slide. Okay, so I've just rewritten where we finished on the last slide. So to simplify or to solve this, I need to do my cube and my square. So when I cube this first guy, I have to cube everything on the inside. So I have to cube the 3 and the S. So 3 cubed, 3 times 3 times 3 is 27. So I have 27 S cubed. And do the same thing for the 2S. So 2 squared is 4 S squared. So let me collect my terms. That comes out to be 108 S to the 5th. So now I can go ahead and plug in my molar solubility for S. And so when I raise that to the 5th power and multiply by 108, I get 1.32 times 10 to the minus 32 for the equilibrium constant. And so calcium phosphate is only very, very, very slightly soluble. It has a very small equilibrium constant for its dissolution in water.